All right, welcome everybody to the webinar today being put on by Plotly and Julia Computing, titled Deliver High Performance Dashboards with Dash for Julia. My name is Alex Johnson. I'm Plotly's founder and Chief Technology Officer. I'm also the original architect of the Plotly.js graphing library. These days, I work on challenging projects across Plotly. Recently, Dash pattern matching callbacks is one of my favorites. They won't come up in today's demo, but they are supported in Julia, and you can find my webinar about them from May on the Plotly website. Matt?
Thanks, Alex. It's great to be here. My name's Matt Bauman. I'm the Director of Applications Engineering at Julia Computing. I've been working with Julia for the past 7 years or so, bouncing between open source contributions and helping Julia Computing, the company, grow and succeed. As Director of Applications Engineering, I wear many hats in the company, ranging from training to working with our products and customers, as well as pure open source development. I guess notably one of the things that I'm proudest of in Julia is the work that I've done with the broadcast system in particular, which is a cool little feature of Julia. If you've not found, check that out.
All right, thanks, Matt. So our agenda for today, over the next hour, we'll start with a brief introduction to Plotly, followed by an overview of Julia and Julia Computing. Matt will give us a demo of Dash for Julia, how these apps are put together and how they work. And then I'll give a walkthrough of the new documentation for Dash for Julia. We'll finish with a highlight of Dash Enterprise features, and finally a Q&A session. Throughout this talk, if any questions come to mind, you can send us to them through the GoToWebinar side panel, and we'll collect them all and answer them at the end of the webinar. Also, let me note this webinar is being recorded and will be shared afterward, along with all the slides and the code. So let's begin. Plotly was founded in 2013. Since then, we've grown quickly, and our open source graphing libraries, which are based on JavaScript, but have clients for Python, R, Julia, and many other languages, have been used by millions of data scientists and included in mission-critical projects at Fortune 500 companies, all the way down to startups. Dash is used across numerous industries, from retail to pharma, energy to finance and HR. And our customers include Shell, Amazon, Invesco, and many others. Data science initiatives often struggle to connect the immensely powerful models being made in the lab with stakeholders making business decisions. Dash Enterprise bridges this gap by enabling data scientists to speak directly to business users through powerful, beautiful, interactive apps. At this point, let me pass the mic over to Matt to talk about Julia and Julia Computing.
Great, thank you, Alex. So Julia is a great fit with the Plotly and Dash team, and we're excited to be a part of this. Julia, for those of you who are unfamiliar or unaware, it's a new modern programming language designed from the ground up to be fast and expressive. So it was first released to the public in 2012, kind of targeting a technical computing audience. The initial blog post that announced it was titled, "We're greedy, we want a fast language that's a high level and easy to program." And from there, we've grown as a community and as a language, and a few years ago hit 1.0, and now is a stable platform for you to build your tasks on. As part of this, we could solve the two language problem, which means that nearly all of Julia's packages are written in Julia itself. It's a fast enough language that allows you as a user to write core numeric routines. In short, it means that for loops are fast again. You don't need to bend over backwards to hit library functions. You can write your algorithms in the natural way, and you can get speeds that are like C or Fortran. This has led to huge acceleration in in pickup and use with over 1 million downloads a month. And in the language of programming languages, we are a dynamic language with a just-in-time compiler that kind of looks at what arguments you're passing and makes sure that we have the specialized code ready for you to use and run. Of course, it's an open source ecosystem targeting now general purpose computation. It's kind of extended beyond its initial mandate and really strives to be reproducible for reproducible data science and analyses. So this has led to lots of pickup in the press, from Ars Technica to Nature. I encourage you to go look and see what folks are saying about us. At Julia Computing, we kind of strive to support folks using Julia in enterprise. So we were founded by the creators of Julia back about 5 years ago, out of a need that arose from the community saying, hey, we can't just rely on open source tools here. We need someone to yell at, we need someone to fix our bugs for us. And so that's where Julia Computing came from. And out of that founding story, we now employ over 40 folks, lots of people engaged with open source development of Julia itself and its packages, and we're well placed to support the language, as well as now we're building infrastructure to help companies deploy and use Julia in the cloud. And this ranges from lots of domains, from pharmaceuticals to energy to medicine, some of the same clients, in fact, as Plotly-Enterprise uses. And so we see this as a great place to engage with folks. Julia Hub is kind of our signature platform that allows you to explore the ecosystem. So you can go to juliahub.com, see the Julia ecosystem, and then if you log in, you're able to actually run code on the cloud and get things going. It allows you to easily scale your Julia programs to the cluster in the cloud, kind of makes your laptop feel like the head node of a cluster, and allows you to go up to many thousands of cores and even GPUs and heterogeneous compute on that. So the public version of Julia Hub is up and running today. You can easily run code from your IDE. It automatically gathers everything that's in your IDE and gets it up and running for reproducibility. We even have $25 in free compute to get you started. And then of course, we also offer the enterprise version here that, it adds functionality to that for things that teams in companies need, like private package management, registry management. We can work with you to even deploy things behind firewalls and air gaps. Of course, if you're behind an air gap, you can't hit the compute in the cloud, but we can work with you on those things. Governance and security, and even deploying into your own cloud account on AWS or Azure. These things are where we see Julia going as we start, building up HPC computing much more powerfully and robustly. So all these things together come to create a perfect team between Dash and Julia. Dash is, of course, the open source dashboarding and visualization library from Plotly, and it has an open source core. It's reactive. It allows you to inspect and plot your data easily and beautifully, and uses the plotly.js to visualize things, and has really nice interactivity in general. Powering that interactivity, you want to have callbacks to do some data wrangling, right? To munge your data, figure out, look at different subsets or different slices of your data. And Julia is a great answer for that side of things. It also, is an open source language, and it has a very expressive and terse callbacks, which is exactly the kind of idiom that you use in programming Dash, with callback kind of mechanisms, where the reactive core in Dash will call into Julia and back and forth. And when you do that, you want to wrangle your data efficiently, right? You don't want your end user waiting for long. So the high performant, efficient code that Julia generates is great for this. The fully reproducible pipelines means that you can, deploy your Dash application and know exactly where things came from. And then, of course, you can leverage all the great packages in the Julia ecosystem targeting data science, machine learning, many computational tasks, and more. We now have over 4,500 packages in the Julia ecosystem. So all that is at your fingertips. With that, I want to show off just a pair of demos here that I think will be helpful to understand. The first one that we'll do is just kind of a bare bones how to get started with Dash, right? It's a lot of fun to talk about this, but let's see how it looks to build a Dash application from end to end in Julia, how you would go about doing that. And then at the end of that demo, I'll switch gears and talk about a different app that I created actually about 5 months ago now that's been running happily and kind of speaks to the stability of the ecosystem here. I've not touched it in a very long time and still doing its thing, so we'll take a look at that secondarily. But first, let's talk about the demo on the left here. This is going to be an example coming from machine learning. It's kind of the hello world of visual machine learning models, where you want to do a convolutional network to identify handwritten digits. And so I want to create one of these models in Julia and then create a dashboard that allows me to play with that model interactively. So we'll see how that looks. To do that, I'm going to jump over to my Visual Studio IDE, where we can see my Julia code and see how this all looks. I have some things already written for me. Since this isn't a machine learning Julia seminar, I'm not going to talk much about the machine learning network. The idea here is just we have a bunch of handwritten digits. We want to classify them into saying whether they're written down as a 0, 1, 2, 3, or 4, whichever digit they are. To do that, I have a model definition here. I can jump over and see what that model looks like. And it's just a deep neural network, as you might expect if you come from machine learning literature, with a bunch of convolutional networks. In fact, 3 layers of convolutions, and then a dense neural network at the end to give me my 10 final outputs. And this is what a machine learning model in Julia looks like. Now, the way we have this defined is, this is a deep network that'll take a while to train on my laptop. And we have this set up so that way it can actually run on GPUs if they're enabled. Now I'm on a Mac laptop that doesn't have a general purpose GPU attached to it, so I don't have that capability built in. And if I were to try to run this locally, it would take about an hour to complete. We don't have an hour to do that. So let's connect into Julia Hub to launch this and deploy this application on the cloud to run and train my model here in the cloud. So I'll jump back to this training file, this main file that'll run the training, do a test, and then output its accuracy. So I have this set up in Julia Hub. We can do this, and then we can create a cluster in the cloud on demand. I can choose what each machine looks like, how many cores I want each machine to have, how many nodes I want to have in my cluster. In this case, I don't need a cluster, I just need access to a GPU. So I can use one node, set up a GPU. Let's use a beefy GPU with 16 gigabytes of memory on it. And now I can choose how much time this should take. I know already that this will take less than 15 minutes. So I can put a time limit here just to make sure my cloud compute cost isn't unbounded, and hit start job. That'll connect to Julia Hub. It'll bundle up all my code here. So that includes my model, all the dependencies, all the packages that I need, get them set up in the cloud for me to run. And it's as easy as a single click here to do that. So we'll do that. It'll connect into Julia Hub. It's submitted my job here. And then I can go in and watch these things, watch the model be trained live. Now, I don't want to sit here and wait a few minutes for the machine to spin up. So instead, I'm going to pull up a video of this training in action, where you can see, it connects in, loads all my packages. I'm going to jump ahead a little bit here to where we're running the meat of the script. It's going through each iteration here. You can see it goes in, runs an epoch, prints out its accuracy, and if it gets a better accuracy, it'll save it out. Now I can go back up to the top of my plot and graph these things live. So as these logs get filled in, I can plot the epoch that we're on and against the accuracy. And this is actually a Plotly.js plot here. it's a great visualization engine that Julia fully supports. And we have this at your fingertips as things are training. So this is a live view. Well, it's not, it's a recorded view, but it's real time of our model training and going through and getting things, finding the best answer as it goes. And then of course, once it completes, I can go hover over these points, these data points, and introspect things, and as Plotly is very good at doing. So that's the way this works. I'll pull a cooking show example where we can then download the trained weights from a run that I just ran earlier today. So I can click this results button. It'll download it. I can save it or copy its path or open it. But what I want to do here is I want to introspect those things using a dashboard. So how would I do that using Plotly Dash? Well, let's start a new file here and pull in those packages. I can add them using the Julia package manager. It's as simple as saying add dash and hit enter. That'll add the core dash package to your environment. I've already done this, so it shouldn't do anything here. But that'll get things set up for you and get them running. You can then also add in a bunch of other things. So there are a bunch of helper packages alongside the main dash package, and I'll add those in as well. So if I just hit dash and hit tab, you can see all of these options. I'm gonna want to add in the HTML components and the core components. These are kind of the packages of elements that I can put into my GUI. So once those are added, I have those already added, I can just, using Julia, say, let's using dash core components, dash HTML components, and that's how we can bring those into our namespace. We'll want to, set those things up. So now I have those packages loaded. How do I define a dash application? How do I, begin building this? Well, it's as simple as saying I want a dash app. And in fact, because I'm in VS Code here, let me make this a little bigger, and I can close out Julia Hub to focus on the code that I'm writing. Because we're in Julia Hub or in VS Code here, I have great, handy IDE help functions. So just hovering over this dash function gives me great documentation. And this documentation, Alex will talk a little bit more later on in the presentation about how it's built and how it's hosted and how you can see it online as well. But it's also at your fingertips right within Julia using Julia's built-in documentation. And you can see here how to work this. There's a lot of ways of modifying it. I'm just gonna create a basic application for now though. And the basics here are to say, well, we have an application. Now let's set up a layout is kind of the terminology we use. That's kind of the HTML template of the application itself. And now we'll use some of those HTML components we loaded in from the HTML components package. We'll say, let's create a div because that's a nice way of encapsulating your app here. We'll do this like this. This is just going to create a div section for us. And we'll structure this using a do block, which is kind of a fun way of structuring your code. It actually creates a callback, but in this case, it creates a really nice visual analogy to the actual HTML code that you're going to use. So this is just like a div tag in HTML. We'll spell it in Julia instead. Now I want to just create a simple header here that says hello dash plus Julia webinar, like that. And that's it. So let's execute these things, get them all defined. And now I want to serve this, right? And so to serve it, we just simply say run server. We want our app to be run. I'll run it on my local host here and do it on a given port like this. So this will just run on my local computer to get things going. And you can see we started it up, got things loaded. And now let's pull this in. We can bring this over here, load it up, and sure enough, we have our web page. Now this leaves a lot to be desired, right? It's just a static web page with the header in it that says exactly what I just wrote. So let's go back here, and now let's make this more complicated. What do we want to have happen here? Well, we want to have an interactive GUI that loads our model and then deploys it, will allow us to introspect it and play with the code. So to do that, I'm going to jump ahead a little bit and let's copy and paste some things that I've already written down. So the first thing here is let's load in our model definition and the trained model, that model that I just trained in the cloud very quickly and efficiently using Julia Hub. So we can load in the trained parameters from our model. The Flux is our machine learning environment. I'll need just a few other packages to do this, like that BSON package that in which things are encoded. So that will, load our definition, get things up and running for us here. So I'll define all these things, get them going. Now, I also want this to plot, right? I want to display a plot of what the output of my machine learning architecture is. So in order to do that, we will use plotly.js to define these things. So let me run these. Okay, and then we'll use Plotly as our plotting environment. So using Plotly, and in fact, I'll just use the base infrastructure of it. We don't need all of the bells and whistles of Julia displaying Plotly because we'll display these in our environment to get them going. So that gets us our plotting environment. And I have a nice little layout that I've already fiddled with a little bit that simply, sets up my x-axis, my y-axis, and the way that I want them to be. You can see exactly how these things all get set up and are nicely and easily specified using Julia's keyword arguments here. So I can set up a layout for my plot. And let me just create a placeholder plot here that, gives me a plot that has an x-axis of 0 through 9. Those are the digits that I want to be identifying, and gives them all equal weights, right? We don't know what the model is going to do yet. We'll set this up as our plot and get these things going. So let me define these. And now I can go in and add that plot to my web page here. So I can say, now I'm going to want to use a --core component that is a graph. And I want to give it an ID. So this is like your HTML ID here. We'll just call it the plot. And I want the figure itself to be that placeholder graphic. So that will set up this. And now we have a new layout, right? We have our graph and our placeholder graphic. And we can now run the server again. So let's pull up our local host. And if I just refresh this, now I have my Plotly graph. We're still missing some components here, right? Now we're just saying, well, we have 10% chance of being any one of these digits, and we're not able to draw in any digit to test it out yet. So we want to make this yet a little bit more complicated. We want to add in a canvas element. And to do that, we can simply use those HTML elements to add a canvas. And again, want to give it a HTML ID of our canvas. We want to, we could say a given width of 200, a given height of 200. And these are just, the same kind of HTML parameters that you pass in, right? It's very easy to do this. And in fact, I can even add a style here as a named tuple in Julia. So I can say, all right, our style is gonna have a margin of auto to kind of center things, and we'll display it as a block, this. So that gives me, a really nice and easy way of adding a canvas element. There's a little bit of a trick here with that canvas element, is that I want to automatically load some JavaScript code that will allow me to scribble on my canvas element. And to do that, we'll add some support here. So I have a little bit of JavaScript code that I've already written in a file. I've actually written it in Julia, but you can write JavaScript code in Julia just fine. And then the fun thing here is now we want to define callbacks. And so what we want to do is we want to add some intervals to kind of set up the guts of our app here. So we'll add some intervals, get them going. So we have a loader that will set up the canvas elements, and we'll have an updater that will, grab the data from our canvas element and give it to Julia. And so those two things are there. Now we have a callback that simply says, hey, when that loader timer triggers, well, let's set up our canvas with all its JavaScript code. And when we're done, we can set the loader to be disabled, and we don't need that timer to be running anymore. We can then also have that canvas export function set up here that just simply grabs the data from our canvas and gets it going that way. So this all together, taken all together, gives us the ability to put in our canvas. We need one more thing here, which is that store, in which we're going to store the data from the canvas to pass it off to Julia. And again, that's just a DCC store. And as with all of these things, you just hover over it and it'll show you its documentation nice and easily like that. So now we have all the components here for our graph. Let me just add one more thing here, which is a button to clear my screen. So I'm going to go in here, add an HTML button. Again, this is a core component. I give it an ID and a name. Again, I can set that style very similarly to how I did the canvas. And these IDs are important because they're how I identify what inputs and outputs I want to do. So what do I want to do when I call this HTML button? Well, I want it to clear the screen, clear that graph, and that's defined in my canvas setup as well. The last thing, the big magic here is, of course, updating our figure, right? So we want to, given our figure, right, given the data in our input store, we want to output a new graph to our figure given the probabilities after running our model. So here's that model that we loaded up. We define it, set it up, pass in our data the way we want it, and get out a list of probabilities, and we'll plot that. And so this is a very, very simple way of getting things going. All taken together, we can go in here and get this all put together into one final thing where we can include our board.jl and get it all set up and running. That'll, again, define these things, and we should be able to get that going. As that's loading, I'm going to jump over to the concrete example of the other graph, the slightly more complicated version of how you can do this, how you can get this all up and running. The main thing here, yeah, let's just pull that in. So this is a separate application now that I've been running I've deployed onto Heroku and got running for a long time now. It's a simple graph that kind of slices and dices some data that the New York Times has compiled on COVID-19 case counts. And this is fully responsive, and it's a much more complicated GUI than the one that I had shown before, right? Where we can go in and say, let's grab in New York City, for example. So New York and New York City. And as you select what state and county in the United States you want to look at, you can refine and add more data here. This is all fully reactive, and every time I change something, it's actually calling a Julia function that'll munge through the 600,000 rows of data that the New York Times has aggregated, and do so on a completely free Heroku server that's very limited memory, very limited bandwidth, process compute power. So let's pull in a few more cities here. So I can grab Chicago. I can grab California's Los Angeles, for example, and all of these things are graphed right next to each other. Of course, if I'm graphing lots of different regions, I probably want to normalize by population. And all of these things are set up exactly the same way that I showed you already, where you can go in and play with these things. Of course, this is a Plotly.js graph with all sorts of great ways of comparing your data and drilling down and understanding how it works. So that's kind of the end goal here. The data and source for this is, of course, open source as well, and you can dig in to how this looks. You can see that I've not touched this for a long time, and yet it still happily grabs new data. This data set has grown tenfold over since I've defined this, and Julia is happily working with this. You can go in and see exactly how this is defined. Now let's go back to my dashboard here that's up and running. Hopefully I can refresh, and now I have all the components that I've been talking about. I have this graph here where you can go in, and then as I draw, my machine learning model is giving me my probabilities. Now this is definitely a 2. You can play with this and try to fool it, and that's definitely a 1. We can get some sort of ambiguous thing like, is this a 3? Is it a 2? I'm not sure what that is. Lots of fun to be had here in different ways of playing around with this. But this is using Dash, running a machine learning model, a full end-to-end example. So with that, I want to hand things back off to Alex to talk a little bit more about how Dash is architected and how the documentation looks, and how you can dig in on the web side of things.
All right, thanks, Matt. Let me just get this running. Okay, thanks for that great demo, Matt. If you're excited by that and you're starting to wonder how can you start using Dash for Julia yourself, the next thing I want to do is talk about our documentation. So we've got our documentation up and running at dash-julia.plotly.com. One thing that I'll note about this, just like the Python and R Dash documentation, the Dash for Julia docs are a Dash for Julia app. So why is this important? Well, number one, we want to dog food our product, meaning make use of it and push it to its limits and make sure it's really up to snuff. But also, that means that most of the code samples that you see in these docs are in fact running next to an executing version of exactly the same code. So that's really cool. You can see all of the source code for all of the flavors of Dash. Oops, sorry. You can see the source code for all flavors of Dash over at the Dash Docs GitHub repository. This is entirely open source and contributions are welcome. One last thing I'll note before diving into the Julia docs. As we're fleshing out the Dash for Julia docs, you'll notice a few things are still missing. You may want to head over to the Python docs, which are somewhat more complete, particularly for usage of specific components that's nearly identical across all of the languages. So what does this look like? So here's the Dash for Julia documentation page. You'll see that it starts with an introduction and some things like a Dash app gallery with some ideas of what people have done before to get you started. It has a step-by-step tutorial for how to use Dash and how to put your apps together, and finally a section on deployment. Inside the tutorial, we start with installation, and the simple way to do that, as Matt showed in his demo, simply using the built-in Julia package manager. You add Dash, Dash core components, Dash HTML components, and Dash table. And then we'll jump into making an app. So the first thing is how to create the Dash app and set up its layout. You'll see that here we create a simple app with a little bit of text and a graph, and voila, down below, here they are. examples on the site are interactive. So for example, here we get to the tutorial on basic dash callbacks. This makes an even simpler app with an input and an output and a callback that puts them together. So you can see you've entered initial values where we start, but if you start typing that code, you'll see the output changes to reflect exactly what we've typed. So this is a fully interactive example. Like I said, we hope this is easy to use, and we hope that it answers all your questions. But if you have any suggestions for ways we could make it better, feel free to head on over to our documentation repo and either raise an issue or make a pull request. Finally, I'll note that Dash for Julia itself is fully open source, and you can see everything that goes into it right here on the dash.jl site. All right. Now let me talk just a little bit about Dash Enterprise. Everything we've talked about so far relates to Dash open source, and that is the core analytical application UI, but there's a lot more that you can do with Dash Enterprise. This is all separate pieces that build on Dash open source. Dash Enterprise can be hosted on Azure, AWS, GCP, or on premises, including air-gapped installs. Once that's up and running, you'll be able to deploy Dash apps securely within your corporate environment and leverage all of these features. Dash Enterprise tech stack roughly falls into three sets of capabilities. One for machine learning operations features, one for low code app building, and another for enterprise AI features. Some of the features that I think are most interesting for Julia users might be this Kubernetes scaling and the job queue, which we anticipate integrating with Julia Hub in an upcoming release so that you can expose virtually unlimited computing power to your business stakeholders. And the low-code features, these are things that help you write your apps faster and do things like embed your Dash apps into larger existing applications. One of my personal favorite features is workspaces. This is an onboard integrated development environment for data scientists and model development. This can help new team members to be productive with Dash from day one without installing anything on their local computer. And this also allows multiple development environments for each branch of work, so different team members can be collaborating on the same app really easily. All right, with that said, I think I'd like to open up the floor to some questions.
Yes, if you have any questions, please put them in the questions box. We already have a number of good ones. Alex, this looks like a good question for you here. There are lots of great, Dash component libraries. In particular, there's this component libraries that uses the Bootstrap theme. Is that Dash Bootstrap component package available for use, and how would you use that in Julia?
That's a great question, Matt. To be honest, I don't know whether Dash Bootstrap components has been made available for, no, I believe it has. I believe Bootstrap has been made available for Dash Julia. If a component has not been made available yet, there is essentially a one-line change that needs to be made to the component building script inside each component. So that what that means is it's quite simple to enable that if you find a component that hasn't been made available. But yes, all the core components, and I do believe that includes Dash Bootstrap components, are available for Julia.
as someone who's done none of this work, but has kind of watched it be done from afar, that's, I think, the large bulk of what went on in making Julia a fully supported language here is getting that auto generator for component authors, right? That now if you're a component author for Python and R, you can easily add Julia with that one line of code. And so I do believe that Dash Bootstrap Components is available. I don't know if it's publicly registered yet, but should be in short order.
All right, let's see. Here's one.
Oh, go ahead.
Oh,
yeah.
Here's one for Matt. What is your advice for incorporating Dash for Julia into an existing Julia workflow?
That's a good question. I think, the way that I would do it is, kind of like how I did with my, machine learning model here. I had my training file, which is kind of my main entry point. I had my model definition, and then my dashboard can live right alongside it because of the way that Julia's projects work and environments work. You can manage all the dependencies right within that same environment. You can even have a nested environment where there's special packages that are only required if you're deploying the dashboard. And so it's kind of a nice way of tailoring your app that way. We're working on making some solid idioms here for for example within Julia Hub, where you could have an application that exposes a dashboard that you could then run directly there. That's some upcoming work that we're doing. In short, both Plotly and us at Julia Computing see a really positive engagement between the two companies and working together to see how we can best support the community in this way. Question for Alex here is, do you have to know JavaScript in order to use Dash and Dash for Julia, or is that something that's helpful, or is it not necessary at all? What would your input be for that question?
Yeah, that's a great question. For the most part, the answer to that is no. You don't need to know any JavaScript in order to get most apps working. I know in Matt's example, there was some JavaScript used kind of behind the scenes in order to pull the data out of the canvas. There are a few specialty applications like that, also some performance cases where you need to do something really simple and you want to avoid a server round trip. You might want to use some JavaScript, but in general, the answer is no. The whole point of the Dash component ecosystem is to have already done the JavaScript for you. So all you need to write is your Julia code in order to access that full functionality.
My knowledge of JavaScript is very limited, and I was able to just copy paste someone's working Canvas JavaScript and get that going. Canvas is a little bit of a tricky element to use in general, but for the vast majority of elements, there's zero JavaScript required.
All right, here's one for Matt. What would you say are the main arguments for switching from Python to Julia? And if compute speed is not an issue, would you recommend it? And what would you say about that?
Yeah, that's a question we get often. And really my answer there is that it's not necessarily a competition. If you're happy with Python, charge right ahead and use Python. But if you're feeling some pain points, then Julia is a great option for you. There are some exceptions there. There are some now first-in-class packages being developed in Julia that aren't available elsewhere, and some really awesome composability between them. And this is in particular when it comes to advanced machine learning techniques. Julia is a fully differentiable programming language. And because all of Julia's packages are written in Julia itself, it means that you can do things that are relatively crazy, like differentiate the whole way through a differential equation solve. And do things that hadn't been considered to be possible before. But really, we see ourselves as happily coexisting with Python. You can call into Python. We have really awesome interoperability between Python and Julia. And we're even working to build Python packages and R packages in Julia itself and exposing that functionality to those languages, so folks who are comfortable working in those languages can get the speed benefits without even knowing that they're running Julia. Kind of like how Python and R libraries these days are often written in C and C++. Julia is a fast language on that same order, and so it's a nice implementation. And so if you're not feeling compute, the need for compute, then that may not be a compelling use case, but there are maybe other reasons to use it as well.
One thing I'll add to that answer is the Dash ecosystem is designed to make switching languages easy. When we introduced Dash for R last year, we started seeing community members on the Python side helping people on the R side and vice versa, because the syntax is designed to be extremely easy and comparable between the different languages. So if you start out in Python and find a reason to switch to Julia, by all means, you should be able to simply port your application over with very little fuss.
So on those lines, there's a good question about, are there plans to have all of Dash Python's functionality available within Dash for Julia?
There are. Looks like someone may have asked about data tables specifically.
Yeah.
Those have not yet made it into the Dash for Julia docs, but they are in fact available and registered. And as we go along, any remaining stragglers and remaining features that haven't been implemented on the Julia side will be added.
I'll note that that app that I used that displayed some of the COVID data, I built that before there were Julia documentation, and I actually found it relatively easy to use the Python documentation in Julia. The two languages are fairly similar, and similar enough that I could easily do the translation. I mean, they're all using keyword arguments and things like that, so it's really not that big of a lift. It's nice. It's really awesome to have the Julia native documentation. But even where that's missing to this day, it's easy to work around, and eventually it sounds like that'll be rectified in short order.
That's the plan. All right, one more for you, Matt. Do you have any advice for deploying a Dash Julia app within Docker?
That's a good question. I mean, I guess I'll answer that by not answering it, and by saying, if you go to my COVID my COVID dashboard source code, on the README there's actually a deploy to Heroku button, and that sets things up with a Docker container without you even needing to worry about Docker. And it has the build pack and gets things going that way very, very easily. You can simply define which version of Julia you want, and it'll set up all those things for you. So the easiest way to do it is to not use it directly, but use a service like that. You can, of course, manually build these things up yourself using the straightforward community components. The one trick that I would point out is that, especially for a service like Heroku, which is a very limited free service, you can pay for more power, but lots of folks like it for its free ability to deploy web pages like this. You need to stay within their compute limits. And because Julia defers compilation to runtime by default, it kind of waits until it sees what data you're going to crunch on and compiles dedicated functions and specialized functions that can work on them very, very quickly. That compilation time can be a little bit of a barrier to starting up apps on a dime and doing it very quickly, which is the model for Heroku, is that they'll tear down your app and start it up on demand. So in order to fit within those constraints, you can look into using a tool within Julia called Package Compiler. It's a really awesome package that beyond just compiling packages, it allows you to compile whole applications and do a lot of that compilation time ahead of time, making Julia a little bit more akin to a compiled language like C and C++, where you can do that work ahead of time and have it sitting in your Docker container ready to launch on demand. So that would be the one thing that I would look out for. And in the build pack that I'm using, we're working on making that more fully officially supported. It kind of walks through how you would do that and how you would make that work. Alex, on your last slide, there was a bullet that talked about no-fuss authentication for Dash Enterprise. How does this mean, and what does it mean when you set up enterprise apps?
Yeah, that's a really good one. What we've done within Dash Enterprise is set up a whole bunch of different connectors that make it very easy for you to integrate your Dash app with all sorts of different common identity providers in the corporate environment. So we've got LDAP, we've got SAML, Active Directory, et cetera, et cetera. And what this means is that you configure that within your Dash Enterprise instance once, and then it's available to all the apps that are deployed there just to simply take advantage of your signed in users. So you can see that at the page I've opened here, plotly.com/dash/authentication. Matt, question for you. Is there something similar to Flask caching or memoization in Dash in Julia?
Yeah, there's great memoization libraries in Julia that you can use. In fact, I think the de facto one is just called memoization.jl. You can explore those on Julia Hub, find them, and it's as simple as using what's called a Julia macro to say, hey, I want to memoize this, which simply means that if you see the same function run with the same arguments, it'll use a cached version, and that's a great use case here to speed up repeated uses and repeated computations. So that way you don't always need to be recomputing these things. And it actually fits really nicely with the Dash server model, where you can cache these once for the entire crew, and all the users can see the benefits. Let's see. Then there's a question about, is it free to publish a web page with dash.jl like you can with rshiny? This is someone who's trying to switch away from rshiny because they are doing intensive computation using GLMs and such, and want to make an app for non-stat folks, but they want to be able to build a free website. So how would you go about publishing a website like you would with rshiny?
Yeah, that's a great question. As Matt's COVID example showed, you can get quite a ways with a free Heroku app. And the power of Julia means you don't need a whole lot of computing resources on the back end to make something pretty powerful keep going. Obviously, we at Plotly think there are a lot of advantages to doing this with Dash Enterprise. But if you're looking for something free and basic, definitely a Heroku deployment is not a problem at all. We currently have the Dash for Julia docs deployed on Heroku just to make them more easily publicly available to everybody.
Nice, thanks, Alex.
And a question for you, Matt, that I expect we'll both want to talk a little bit about. Will Julia Hub be integrated with Dash Enterprise?
That's a great question. So, both Julia Computing and Plotly are, striving to make these open source ecosystems easier to use within companies. And so, we as companies, part of this joint webinar is our collaboration here, not just on the open source side of things, but also on our enterprise solutions. And so, cooperation there is ongoing, and we hope to be able to, for example, within, Dash Enterprise, be able to call out to Julia Hub's API to kick off, big compute tasks, like we had seen with the MNIST example, being able to, not just display the outputs, but also rerun them and try different things, try different settings on your big compute tasks. Vice versa, within Julia Hub, we can see, reaching out to Dash Enterprise to have the nice swanky style sheets and extra bells and whistles that they have available within Dash Enterprise. So there's a really nice cooperation between the two companies, and I think a really positive outcome for everyone as a result.
Yeah, that's right. I think there are a number of ways this collaboration between Julia Computing and Plotly could continue. We do intend to build out Julia support within Dash Enterprise in an upcoming release, and exactly what that looks like in terms of Julia Hub still remains to be determined. But if you have an application that you think would benefit from this, definitely reach out to us, and we will work on it with you to make it a reality. All right, with that, I think we are out of time, and so that wraps up our webinar. Thank you, everybody, for coming. I want to thank my co-presenter, Matt Bauman, and the Julia Computing team for working with us on this webinar. Look out
and
for
likewise, thanks to the Plotly team for jointly hosting this with us. It's been a lot of fun talking with you about this.
Absolutely. So everybody who registered for this webinar, look out for a follow-up email. We'll be sharing the recording of the webinar, all the code that was involved, as well as some additional resources to help you get started with Dash for Julia. So thanks a lot.
Take care, everyone.